Everyone, and welcome to the second part of the automatic machine learning using AutoKeras tutorial. In this part, we will continue developing our little program here to be able to run the model that we have built in our part 1 from this tutorial. So we'll make uh, the font a little bit larger to be easy to be read. So once the auto model is fitted on the training data with these parameters, we can also call evaluate method using the test data and the test labels, which are loaded here from the Cipher10 repository. Um, Next, we want to save the model using the export model, and we also want to uh, save a version of the architecture that was the best option from the 20 trials of the AutoKeras model that we have built. And for that, let's assume that the JSON file is called AutoML as the name that we gave to our auto model. So we open this for writing, and then we just write the model. And secondly, what we want to do is to save the weights of the auto model that has obtained the best accuracy from the maximum number of trials. Okay, so just to print a message that the model was saved successfully to disk. And now let's make a prediction about this testing samples. And now we're going to import from scikit-learn, the popular Python package for classical machine learning. We will import a method for reporting the results that is called classification report, which takes the true labels, the test wise, and then the predicted labels from our best auto model, and it uses the target names as the label names that we have defined here, as they are taken from the Cipher10 um, database website. Good. So once we have generated this report, um, what we want to do is to save the report in a file using an output path in a directory called output. Let's say we want to save it in a result.txt file. So we open this file for writing, and then we write the report, and then we finally close it. Okay, so that's basically the main function um, that we have coded to make use of the AutoML part that was generated from this architecture, and exploring the hyperparameters of the convolutional blocks and dense blocks that we have used to build the model. Good. So now let's see what happens if we run this. Okay, so I'll just run this file inside the PyCharm IDE. So I have a GPU on this machine, a GPU with 4 gigabytes of video RAM. So we see now is loading the data. Okay, um, it gives some warning here that is allocating some. It needs some more memory. So apparently my video card doesn't have enough memory. So now let's see. epoch 1 of 40, we'll hopefully see some progress with the training. Okay, so first epoch is done. We see here the accuracy, the validation loss, and the validation accuracy, and this epoch took 20 seconds to run. We see now the second epoch is finished, so the validation accuracy increased to 0.48, and the third epoch is now running. We see the validation accuracy increasing.